everyone, I am Assistant Professor Urmi Shah from ICT Department of LG Institute of Engineering and Technology. We will be continuing today with the Amplitude Modulation Scheme module, which is chapter number 3 of your course, Analog and Digital Communication. So in the previous session, we have discussed what is amplitude modulation, what are the variations possible in amplitude modulation, what are the different types of modulating the amplitude modulated signal, what are its advantages, what are its disadvantages, everything we have seen in the previous session. In today's session, we will be looking upon more on amplitude demodulation scheme. Now basically what is demodulation? Once all of us have discussed about modulation, that means if we are having the transmitter end, if we are modulating the signal from one end to another end, that is your receiver end, once the signal is received at the receiver end, we need to retrieve that signal back from receiver end into the original message signal which was transmitted from the previous end. So that reproduction of original message signal is known as demodulation. Once we perform modulation, at another end we need to perform is demodulation of signal. So that we are going to see in this session. So let's start with this session. In today's session, we are going to cover following topics, that is generation of amplitude modulated signal using amplitude modulators, that we will be seeing what are the types of modulators available in market if you want to perform amplitude modulation, what are amplitude demodulator circuits, how we will perform demodulation of signal, and what is amplitude modulated transmitter, that we will be seeing in this session. Basically, amplitude modulation is performed using these two types of amplitude modulated modulators, that is square law modulator and switching modulator. These are the two types of amplitude modulators which are frequently used in industries as well as in market. So what is this square law modulator and what is this switching modulator, that we will be seeing. Basically, square law modulator is having one adder unit where your message signal and the carrier signal amplitude is multiplied or it is added up, that is your summer block. So here your V1 signal is having m of t plus AC cos 2 pi FCT term. Now this will be passed on to the square law device, and this square law device is going to generate the squaring of the signal which was given to this square law device. That will be your next input V2, that will be passed to a band pass filter, and the final S of t will be your modulated signal. Band pass frequency will pass the range of frequencies which are there in its range, otherwise rest of the frequencies it won't pass. It is going to pass some limited amount of frequencies which are allowed in that specific band. So basically signal V1 of t is applied as an input to the non-linear device, that is your square law device, and it is made up of diode circuit. The internal circuit of square law device is made up of diode. The characteristic of diode is known to all of you. Whenever at anode terminal voltage will be higher than the cathode terminal, that diode will be on, otherwise the diode will be off. So forward bias and reverse bias concepts are known to all of you related to diode, that we will be using in this square law device. So this is how amplitude modulated signal is generated using square law modulator. So basically this is the diagram of square law modulator and how this modulated signal is generated, that we can see here using the equations. That is, V2 of t is having k V1 of t plus k2 V1 square of t. Now k1 and k2 are constants over here. It is having two terms, that is the previous signal V1 of t and squaring of that signal, that is V1 square of t, as we have passed our V1 of t signal through square device. So it is going to perform the squaring of the input signal. Basically, V2 of t is equal to K1 multiplied by M of t plus AC cos FCT. So this is your original V1 of t signal which we have seen in this session. So now whenever we will apply this V1 of t in equation number 1, the final equation will be resulted in this way, and solving this equation you will have the final V2 of signal as K1 M of t plus K2 M square of t plus K2 AC square cos square 2 pi FCT plus K1 AC multiplied by 1 plus 2 K2 by K1 into M of t multiplied by cos 2 FCT. So this is the final equation which will be generated by performing the following analysis. So now basically the standard form of square law modulator after deriving everything is like this: K1 AC multiplied by 1 plus 2K2 by K1 multiplied by M of t whole multiplied by cos 2 pi FCT. So this is all about the square law modulators. Now all of you know that Ka is the amplitude sensitivity once we are taking 2K2 by K1 as Ka. So this is a term which is related to constant amplitude sensitivity which is associated with amplitude modulated signal. So whenever we are comparing the output of square law modulator with the standard equation of AM wave, we will get the factor as K1 and the amplitude sensitivity factor as Ka is equal to 2K2 by K1. So this is our scaling factor K1 and amplitude sensitivity factor Ka. So this we can observe by comparing it with the ideal amplitude modulated signal. Next we will be looking upon is another kind of modulator, that is switching modulator. Basically switching modulator will apply the message signal and the carrier signal to one summer block, that is your addition block, and it is going to pass on V1 of t signal to the switching device. So V1 of t is same as we have seen in the previous square law modulator, that is M of t plus C of t is equal to M of t plus AC cos 2 pi FCT. Again this switching diode or switching device is going to transfer V2 of t, that is the output of switching device, to the band pass filter, and it will generate the final modulated signal. Basically switching modulator is also similar to square law modulator, but the difference over here is that diode is operated in non-linear mode, whereas the switching modulator, the diode is going to act as an ideal switch, either on or either off. So this is the difference between the switching modulator and square law modulator. So over here you can see if the carrier signal C of t is greater than 0, or if it is having positive amplitude, at that time the diode will be on and it will generate V1 of t signal. If C of t is having negative values, or if it is present in the negative half, or if it is less than 0, so if C of t carrier signal is less than 0, at that time diode is going to be switched off and it is going to generate 0 signal as V2 of t. So basically V2 of t will be equal to V1 of t whenever carrier signal is having positive amplitude, and it will be having 0 value whenever carrier signal is going to have negative amplitude. So this is the logic used over here as switching device. Ideal diode which is acting as a switch, that concept is used over here. Next we will be looking upon is the equations of switching device that they are generated using the analysis done over here using the summation formulation, and the ideal equation will be matching with the square law device which we have seen in the square law modulation analysis. So over here, once the whole analysis is done, over here you can see by comparing V1 and V2 equations, you can see once the equations are kept in the order, the final equation is matching with the ideal amplitude modulated wave equation. The first term we will consider over here, which will be our desired amplitude modulated signal equation, and the remaining terms we will be neglecting here as they are higher order terms. So only first term we will take, that is AC by 2 multiplied by 1 plus the factor multiplied by m of t multiplied by cos 2 pi fct. The factor again over here is the sensitivity factor, which is in terms of pi and AC terms. So this is, the first term is exactly matching with the amplitude modulated wave signal equation. So this is how modulation is performed using switching modulator. This is the equation where the sensitivity factor is 4 upon pi AC. Otherwise, rest of the equation is same. So Ka is our sensitivity, amplitude sensitivity factor. So now, once the modulators are done, we will be seeing the demodulation part. Instead of modulator, you can use same device as a demodulator to retrieve your signal back. But now we will be passing as an input only amplitude modulated signal, and we will be retrieving the demodulated output using square law device and switching demodulator. So instead of square law device, we call it as an envelope detector. The circuit over here you can see is of diode. It is ended with the capacitor and resistor, which is acting as a filter circuit, which is going to filter out the carrier part, and it will be passing only the message signal, which is your original transmitted signal. So this amplitude modulated signal is given to the diode circuitry, that is your envelope detector circuit, and whenever the voltage across diode will be greater than voltage across capacitor, the diode is going to conduct. At that time the capacitor will charge. So the diode will be in forward bias. Otherwise, whenever the voltage at capacitor end is higher than the voltage at diode end, at that time diode will be off and it will be in reverse bias condition. So at that time the capacitor is going to discharge. So this is the basic working of envelope detector circuit. This way the original message signal will be retrieved back using this envelope detector. Whenever diode is on, at that time capacitor will charge, the message signal will be retrieved, and whenever the diode will be off, the capacitor will discharge and the negative half of message signal will be retrieved. So this way the output of demodulator circuit is going to be achieved using the envelope detector circuit. Now the next is the square law detector circuit. Using the square law detector also we can have the same working, that is if V is greater than Vc, that is the voltage across diode is greater than voltage across capacitor, at that time diode will be conducting, it will be in forward bias mode, it will be in on state. Otherwise if V is less than Vc, that means the diode will be off, it will be in reverse bias condition, at that time capacitor will be discharging. So this is the working of square law detector circuit. So this we have seen as an amplitude demodulated circuit. These are the reference books if you want to refer amplitude modulation and amplitude demodulation. Just the opposite of modulation is the demodulation circuit, and instead of diode circuitry, at the end you will attach a filter circuit which is going to filter out your carrier signal frequency ranges, and it is going to pass on only those signals which are having the frequencies equivalent to message signal. So this is all about amplitude modulation and amplitude demodulation. In the upcoming session, we will be moving ahead with the next module of our analog and digital communication book of our course. Then we will be seeing few more modulation schemes and we will be comparing it with what we have studied it up till now. So thank you very much for watching this session. These are the reference books for this topic. You can refer it and you can have the analysis of what we have studied it here in this session. Thank you so much for watching this session. Thank you very much.